Hi everyone, my name is Sarah Mari. I'm one of the librarians at Portland Public Library in Portland, Maine, and I'm here today to teach you about something. The nonfiction topic that we're going to be learning about today is crows. Crows are black birds that you may have seen outside somewhere. They make a noise that sounds kind of like caw, and they are super smart birds. They belong to a family of birds that are often super smart, and we're going to learn a little bit about them today. We have a lot of books about crows in the library. You can find a lot of them under J59886, which is the numbers that you can see on the edge of these books, except for this one you might notice, because we also have a science comic book about crows. So we have crows books for all kinds of readers, but the book that we're going to be focusing on today is called Crow Smarts: Inside the Brain of the World's Brightest Bird. This is by Pamela S. Turner, and the photographs in this book are by Andy Commons, and there's also some art by Guido Di Filippo. This book is a Junior Library Guild selection, which means it's an excellent book, and it was published by Houghton Mifflin Harcourt. So we're going to read Crow Smarts. You can already see one of those very smart crows right there. This book has a table of contents which tells you the name of all of the different sections of the book. There is a crow smarter than a second grader? Chapter 2, Little Feather. Chapter 3, Tooling Around. Chapter 4, Snip, Rip, Snip. Chapter 5, Meta Tools and Mind Tricks. Chapter 6, Homecoming. And then Ask the Author, Selected Bibliography, and an index in the back. So we're going to start with Chapter 1. Is a crow smarter than a second grader? Munin has a problem. A human has shooed him away into a large cage that is crisscrossed with perches made from tree branches. On one end, a string hangs from one of those perches. On one end of the stick, dangling in midair, is a short stick. The short stick can't be reached by leaning down from the perch, and it's too high to reach from the ground. Two boxes rest on a table at the other end of the cage. Munin glides over for a look. One box is a narrow plexiglass rectangle, open at one end. A small, juicy piece of beef is visible inside. Unfortunately, that fiendish human has placed the treat beyond the reach of Munin's bill. The other box is wooden with slats on one side, like a miniature jailhouse. Inside the slatted box, again out of reach, lies a long stick. What can Munin do to get to the treat? Think fast. If Munin has to, because if he can't solve the problem within a few minutes, the test is over. Now imagine a different problem. You're shown a small treat-filled bucket inside a narrow tube, and the tube can't be moved. The bucket is out of reach of your finger, or a crow's bill. You're given a length of wire. Quick, what's the solution? Here's another test. A treat floats in water at the bottom of a tube, again out of reach. But there are some stones nearby. What's the answer? How do you get the treat? The solutions that crows such as Munin come up with might surprise you. Crows might not have fingers, but they have nimble bills and feet. Crows also have another important quality, one that is rare and special. It's the ability to understand the world around them, the ability to reason and remember, to keep a goal in mind, to imagine and interact, and invent, the ability to create. We call this quality intelligence. Welcome to New Caledonia, where the forests are lush and the crows are geniuses. Here's another look at Munin trying to solve these puzzles. Here are two crows with a tool. Chapter 2, Little Feather. Wah, wah. The begging call of a juvenile New Caledonian crow gets louder as the bird moves closer. A moment later, two sleek, shiny crows land on the log in front of us. We watch them through slits in a camouflage tent. It's easy to identify the youngster who never stops wahing. One small plume on its shoulder is tweaked upward. like a fluffy shoulder pad. The other crow must be Little Feather's mom or dad. It's hard to imagine anyone else putting up with this much whining. 4 little feet tap, tap, tap across the log. Earlier that day we drilled holes in the crumbling wood and filled them with pleasingly plump beetle larvae. The crows twist their glossy heads to peek inside. I imagine them thinking, Eureka! It's a motherload of grubby snacks. Little Feather stakes out a position at the end of the log. The adult bird hops to the ground, picks up a dried leaf stem, and jumps back onto the log. Holding the stem in its bill, it probes the hole with swift, sharp jabs. After a few seconds, it drops the leaf stem tool and sticks its bill into the hole. Little Feather picks up the tool as if to give it a go, but the adult snatches it back, immediately flipping it around. Clearly, it has strong opinions about which end of the stem is the poking end. Yet Little Feather's parent seems dissatisfied. It discards the stem and hops off in search of a better tool. Luckily, the forest floor is covered in sticks, twigs, and dry stems. It's like a crow Home Depot. Here's another picture of Little Feather. The adult returns with a different, new and improved leaf stem. Jab, 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 jab. All of this jabbing isn't intended to stab the grub as you might expect. Instead, the crow is using the tip of its tool to irritate the grub inside the hole. If the crow can rouse the grub's fighting spirit and get the tip of the tool between its grubby little jaws, Little Feather's only contribution is a steady stream of wah, wah, wah. After 4 minutes of delicate work, the grub clamps onto the crow's tool like a bulldog. Little Feather's parent hauls out its catch. It's big and lumpy, a Jabba the Hutt of grubs. The adult crow snatches its prize and zooms into a nearby tree. Wah, 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 wails Little Feather, winging away in desperate pursuit. Wah, wah, wah. The young crow has perfected a technique known by children everywhere. Just keep whining until mom or dad finally cracks. Sure enough, a moment later, we hear the cartoonish glug glug that the fledgling crows make when they're being fed. Little Feather has scored. Afterwards, the forest settles into a comfortable nap-time quiet. The hoot of a wild pigeon drifts from a distant hillside. A soft breeze shushes through the treetops. Wah, wah, wah. Yes, it's Little Feather, acting as if he hasn't eaten since the last ice age, instead of only 2 minutes ago. You can see the crows working with their tools. You can see the big grub. You can see the way that the grub bites onto the stem. And there's Little Feather. Wild crows using tools. It's a startling notion. In some way, tool use is a new discovery. In some ways, it isn't. In 1882, a scientist wrote a report about New Caledonian birds. He claimed that the island's crows carried candle nuts to considerable altitude and then dropped them on a stone or a hard rock to crack them. In 1928, a French travel book casually mentioned New Caledonian crows using stick tools to pull grubs from dead wood. Neither of these reports attracted attention. In those days, scientists believed that only humans had the intelligence to make and use tools. Tools made us special. Lois Leakey, a famous scientist who studied early human ancestors, wrote that tool-making was a step which lifted near man from the purely animal level to that of human status. Louis Leakey hoped that the study of living apes might help scientists understand humanity's ape-like ancestors. He encouraged an animal-loving young woman to begin her first ever study of wild chimpanzees. Her name was Jane Goodall. Jane set up a study in Tanzania, a country in East Africa. On a November morning in 1960, Jane saw a chimp that she had named David Graybeard pick up a piece of straw, poke it into a termite mound, and pull it out covered in termites. The chimpanzee lifted the straw to his mouth and nibbled off the insects. An ape making a tool. Jane immediately sent a telegram to Lois Leakey. Louis Leakey responded, "Now we must redefine man, redefine tool, or accept chimpanzees as human." After Jane's discovery, other scientists found evidence of tool use in a wide variety of species. Some species of ant use tiny pieces of leaf, wood, and soil to carry soft foods, such as honey or fruit pulp. Some species of crab pull small, stinging anemones off rocks and wave the anemones in their claws to fend off predators. Some alligators, during nest-making season, balance sticks on their snouts as bait. When a heron or an egret flies down to pick up the stick, the bird becomes lunch. You have to admire that level of sneakiness. Capuchin monkeys use stones to dig out plant roots and crack nuts. A group of bottlenose dolphins in Western Australia uses sea sponges to protect their rostrums or their beaks as they search through seafloor rubble for bottom-dwelling fish. These discoveries have raised the important question, what exactly is a tool? Is a tool really a sign of intelligence? Scientists now define tool behavior as the use of an unattached object to manipulate something else. Construction projects such as nest building and web spinning don't qualify. A beaver using a branch to make a dam isn't using a tool, but if you see a beaver firing up a chainsaw to cut a branch, yes, that's a tool. Please take a video. So, does tool use always equal intelligence? Scientists think that some tool behaviors are programmed, while others are flexible. Programmed tool use, like the kind seen in ants and crabs, doesn't vary from individual to individual and shows up in every member of the species. It's instinctive, but flexible tool use is different. Not every member of the species uses a tool, and individuals vary in how and when they use their tool. If you're wondering about those sneaky alligators, scientists describe whether the alligator's behavior is truly debate whether the alligator's behavior is truly tool use, since the alligator isn't holding the stick. It's also debatable whether the behavior is instinctive or not. Regardless, scientists are beginning to realize that alligators are far smarter than anyone thought. Flexible tool use by a wild animal is rare. So far, it has been observed only in a few species, including capuchin monkeys, elephants, chimpanzees, bottlenose dolphins, and New Caledonian crows. What's even rarer is the ability to just not just to use a tool, but to make a tool. In this category, the New Caledonian crows may shine brighter than all the other non-human animals, including Jane Goodall's famous chimpanzees. A few days before, Gavin brought the photographer, Andy Coman, and me to New Caledonian Forest to show us a crow tool use in action. We drove past Saramea, a village with a tidy tin roof school and a small roadside park. When the road dead ended, we hiked up a hill to a grove of candlenut trees. Candlenut trees offer a food bonanza for New Caledonian crows. The trees provide grubs and nuts all year round, Gavin explained. Both are a bit tricky to get, but if you can figure it out, you eat well. Gavin showed us a fork in a candlenut tree branch. A large rock directly below the fork was littered with broken shells. Candlenut shells and the shells of a snail that had been introduced to New Caledonia by humans. Instead of just randomly dropping the nut or snail somewhere on the rock to crack it, the crows set it in the fork and push it off, explained Gavin as he pointed upwards. The crows are aiming their drop. It's not tool use, but it shows how flexible their behavior is. By aiming their drop, the crows are making sure that the nut or snail hits the rock, rather than landing in the softer dirt nearby. I smashed a candlenut with a rock, classic tool use, and nibbled some of the meat. Ugh, it tastes like dirt. Try this one, offered Gavin, who was far too polite to point out that I just ate a rotten candlenut. Fresh candlenuts taste like a cross between macadamia nuts and coconut. I cracked open another. Well, I wouldn't eat too much, Gavin said. It's a laxative. Which is a nice way of saying you might have to spend the rest of the day huddled in a bathroom or huddled in the shrubbery. Gavin selects a small clearing among the candlenut trees and showed us how to set up a feeding station. Feeding stations bring the crows in close for observation. We opened our pop-up blind and grabbed a fallen log in front. Gavin drilled deep, narrow holes across the top of the log and on one end. Then we needed grubs to stuff inside. We found a Goliath-sized candlenut log rotting nearby. Between swings with a crowbar, Gavin explained how the crows find grubs in dead wood. They hear the larva munching way down inside. Then they get out a tool and poke in the holes and other crevices. Once split, the rotten wood revealed snug tunnels stuffed with grubs. Pull them out one by one and put them in a plastic box. We need plenty of crow bait for our days of crow observation. Once the crows become accustomed to the feeding station, Gavin will try to capture a few of the birds. He has designed and built a new kind of crow catching net that he hopes to test. Gavin is quiet, versatile, and a competent man, the sort of person who could survive in the wilderness with just a few tools, sort of like the crows he studies. As a boy growing up on a farm in New Zealand, he spent a lot of time outdoors. In his 20s, he travels to Africa to see the wildlife. He returned home to work on the family farm, but nursed a dream. He wanted to become a wildlife conservationist. Gavin didn't start college until 30. In 1993, while doing research for his PhD in ecology, he made a stunning discovery about New Caledonian crows. It happened by accident. So that's their pop-up tent. And you can see Gavin working with a crowbar, some of the larvae they found, and their little bait box. And here is a crow pulling out one of the grubs. I wasn't studying crows at all, Gavin explained. I was studying cagu. Cagu is a rare bird found only in New Caledonia. Gavin wanted to find out how many were left. Since the near flightless cagu, it glides, but it cannot fly, is hard to spot in a dense forest. Gavin counted them by recording the number of calls they made. An area with more cagu calls was probably an area with a larger population. As he hiked through the underbrush with his tape recorder, he often glimpsed crows. In June 1992, he was working near Mont Zumac in the southern part of New Caledonia. Gavin spotted a crow poking a stick in a hole, clearly trying to fish something out. Although in 1972 and 1980, scientists have published brief accounts of New Caledonian crows using sticks as tools, the behavior wasn't well known in the scientific community. Gavin was fascinated. Here were crows using tools just like Jane Goodall's famous chimpanzees. From that moment on, Gavin paid special attention to the crows. On February 9th, 1993, he wrote in his field notes, "One crow up in a tree with a pandas, a plan tool, in its bill. After several minutes, another crow arrived, also with a stick tool that had a hook at one end. Probed a horizontal branch. I could not see the probe site. Both birds then put down their tools next to themselves. I clapped, and both crows flew off. The second bird picked up its tool, though. I retrieved the first crow's tool that was lodged between a vine and a branch. It had black dirt on the probing end." This is the bird that Gavin was studying. That's a closer picture of Gavin. And here are some of the tools that Gavin has collected over his time researching. The variety of the tools that he collected showed the crow's true inventiveness. Some were straight sticks, some tools were twigs that had been carefully snipped and whittled on one end to create a hook, like these ones. Others were made from strips torn from long, stiff, barb-edged leaves of the pandanus plant. Yet the pandanus tools were not random rips. Some were wide, and some were narrow, and some were carefully torn in stair-step fashion. The step tools were designed so that one end was thicker, the better to hold in the crow's bill, while the other was thinner and more flexible, the better to poke in the crevices. And along the edge of the pandanus leaf pointed upward, the better to snag a worm or spider. To observe New Caledonian crows using tools was interesting enough, but to discover that the crows were creating a utilities belt worth of manufactured tools, that was truly stunning. How did the crows become so smart? Here is a picture of New Caledonia in a map. You can see here's Australia and New Zealand, and New Caledonia is part of these small islands that are up here above New Zealand. New Caledonia is a remote group of islands in the South Pacific. The Kanak people have lived there for at least 2,800 years. The English explorer Captain James Cook visited in 1174, and in 1853 France claimed the islands as a colony. Most people live on the main island Grande Terre, which is larger than the U.S. state of Connecticut, but smaller than New Jersey. Lush mountains run along the island's spine, and lowland scrubs fringe the coast. Among the world's tropical islands, New Caledonia is one of the richest in terms of biodiversity, or the number and uniqueness of different species. New Caledonia has many unique reptiles and birds. If you want to see a New Caledonian crow, you'll have to visit the islands. The wonders extend offshore into the reefs of all the different species of coral and reef fish, almost more than the entire Caribbean Sea. Unfortunately, the biodiversity is under threat, though few people live in New Caledonia, they lost 29% of their forests between 1989 and 2009. Most of the forest loss has been caused by brush fires. Hunters set brush fire because it causes rooster deer and wild pigs to the new plants that spring up on newly burned land, but it damages the ecosystem and threatens the native plants and animal. Conservationists are trying to find new ways to control both brush fires and invasive species. Chapter 3, Tooling Around. You can see another crow eating a grub with a tool. You might think that intelligence is a big advantage. After all, humans have big brains, and we're super successful if we define success by a large population. So why hasn't evolution produced thousands of super smart species? Evolution by natural selection means that in every generation, individuals vary. Individuals with quality best suited to their environment survive and reproduce. They leave behind more offspring than individuals that are poorly suited. Seems if a big, complex brain should be helpful to quality. Shouldn't the smarter individuals survive? Shouldn't the dumb ones be killed off? Life has been evolving on Earth for 3.5 billion years. Why don't we see big-brained sharks negotiating peace treaties with surfers? Where are the squirrels with oversized head competing on Jeopardy? As it turns out, big brains just usually aren't necessary. Jellyfish do their thing without any brain at all. Sharks are small-brained, yet they have survived for hundreds of millions of years. If it isn't broken, there's no need to fix it. It's not easy for a big brain to evolve because big brains are quite costly. Brain tissue eats up more energy than any other body tissue, just as a race car burns more fuel than a lawnmower. A big brain requires payoff that makes up for the extra energy it consumes. In addition to needing lots of fuel, brain size is limited in other ways depending on how an animal lives and reproduces. If a high percentage of a bird's body weight is in its head, the aerodynamics of flights don't work. That's why birds also don't have teeth. Teeth are heavy and would overweigh the head. Human bodies have limits too. A baby's skull, and therefore the brain inside, can't get too large because the baby's head must fit through its mother's pelvis during birth. Big brains are rare. Mammals have evolved big complex brains like primates and cetaceans like whales and dolphins and elephants. Among birds, those with the biggest brains for their body size are parrots and corvid, the group that includes crows and ravens. If we go back 280 million years to the last common ancestor of mammals and birds, we find a reptilian creature that was most definitely lacking in the smarts department. From this common starting point, the mammals evolved one line and birds evolved along another. Yet some mammals and birds species ended up with big complex brains. When different species take different paths and end up at a similar point, scientists call it a convergent evolution. Oddly enough, even though their bodies and brain structures are very different, crows and humans may have gone down the same path, leading to more complex about the same time and for similar reasons. Meanwhile, back at the log, you can see Littlefeather and the left-handed adult, who are looking for more grubs. They're using the same tool, and Lefty, what they call the left-handed adult, is teaching Littlefeather how to use crows. They look similar to other crow species, but their beaks are a little straighter. So you can see the New Caledonian have very straight, they kind of look like pliers, whereas American crows have a slight curve to their beak, which can make it a little more difficult to hold tools. These differences might have evolved because they use all of these tools. And now we're learning more information about how crows shape tools. So this is how the New Caledonian crows make hooked tools, by cutting off branches at certain points so that what's left is a little hook where these two branches meet that look like this. Scientists have noticed that all the smarter species live in groups. So what does social living have to do with intelligence? In all of these species, group living probably started off as a defense against predators. A leopard in the bush, a shark in the depths, or a hawk in the sky is more likely to be spotted if many eyes are on the lookout, and a predator is sure to attack a lone individual, but might hesitate to attack a large group, especially if the members of the group will band together to fight off the predator. Once animals create community for protection, other possibilities open up. Members of the group can cooperate in finding and sharing food. They might also compete for the most attractive mate. Regardless of whether you are cooperating or competing, it's an advantage if you can recognize, remember, and negotiate with the others in your group, and especially communicate, and that requires brain power. Scientists think that the intense social lives of humans, chimps, dolphins, and crows may have driven the evolution of their big, complex brains. The challenges of finding food probably also linked to the evolution of intelligence. Some scientists think that species that eat lots of different foods have to work harder to get these foods and are more likely to evolve bigger brains. So we used to think that this was the instinctive brain and this is the thinking brain for humans. But what we actually know is that for the thinking brain for crows, it is this larger part of their brain that is the thinking part. And now we can see that little Feather is learning how to use the tool all by himself. He is able to get the crow out. There are lots of different types of animals about how they eat. So crows have a bad reputation. They're often considered evil, like they're Sith lords, because a group of crows is called a murder of crows. It has to do with their dark coloring, the way that they call to each other in harsh voices, and the fact that they eat things like corn. Think about scarecrows. And they pick out eyeballs of dead things. But here's the real story. Black feathers are the hardiest because they have the most melanin, or a natural pigment that strengthens. And they're technically part of the songbird family. Yes, that's right, crows are songsters. Just think of them as heavy metal guitarists rather than classical violinists. Crows eat farmers' corn, but crows in cornfields are mostly after the bugs. And crows don't eat baby birds. That's a myth. Finally, the eyeball thing. Crows are omnivores, which means they eat all sorts of things. Many other birds specialize in one kind of family. Hawks have a knife-like bill for cutting flesh. Flamingos have scoop-like bills for filtering snails and plants out of the water. And crows have a general purpose bill. It isn't great at anything, but handles most food fairly well, like a spork. There are a bunch of different types of animals that eat things. Carnivores eats only other animals. Herbivores eat only plants. Omnivores eat animals and plants. Insectivores eat only insects. Frugivore eats only fruit. Pizzivore. Just checking to see if you're still awake. Snip, rip, snip. So this one is talking about how tools were created. The earliest human tools were probably sticks, which were used to dig up roots and stones, and used to crack nuts or cut up animal carcasses. Over time, our toolkit improved and expanded. We invented bows, arrows, spears, knives, axes, and eventually everything from X-ray machines to nuclear weapon. We passed on what we learned and built things based on earlier discovery. Most scientists think that cumulative evolution, which is what this is called, cumulative cultural evolution, is unique to humans. However, there are possible evolutions of the pandanus tool that they use. So a crow rips off the leaf while foraging for hidden prey. It was probably wide. The wide tool is stiff and easy to hold, but it's hard to reach into crevices. So next they make it a little bit smaller, the business end a little bit smaller, and now they have a multi-step tool, which is the best. Stiff and easy to hold, more flexible in the middle, and narrow at the tip, like this one, and you can see the outline left behind on the leaf. Now here in this we can see another big picture of a crow with a tool. And on this side, we have approximate number of tools by the number, approximate number of known animal species. 1,371,500. Number of animal species observed using tools, 284. Number of animal species observed making or modifying tools, 42. Number of species known to make multiple kinds of tools, humans, chimpanzees, orangutans, capuchin monkeys, and New Caledonian crows, only 5. And the number of animal species known to make hooked tools, only humans and New Caledonian crows. So you can see they're very smart and they create some pretty awesome tools. Now Gavin has captured a couple birds and he's measuring them, taking a blood sample to make sure that they are healthy and tagging them so that he knows which ones he's captured. And he's also putting them through those tests. You can see more pictures of the animals completing their tasks, like dropping those stones into the water to get the treat to float to the top where they can reach it. And you can see the way that New Caledonian crows are taught by their mothers, but if they have to be taken by humans because of injury or their parents dying, the humans can also teach them. And finally, here is Guido, who makes some of the art with the drawings that he has been making from the crows and helping the tools for the tests, which Moonin is able to use to solve all of those problems that we talked about. And now all of the crows that Gavin used to study are returning back to their homes. You can see with the crows, and then they fly away. Here they are, home at last. You can see the beautiful pictures of the crows. Now, in the back there is Ask the Author, which is questions with Pamela Turner, who is this person on the end, who wrote this book. And there is also, after several pages of questions, a selected bibliography. So if you really wanted to learn more about crows after reading this book, and you had already read all of the ones at our library, you could look for these books, which are lots of things that the author used to help write this book. There's also an index, so if there was something specific you wanted to know about crows, like you wanted to find out a little bit more about juveniles, here are all the pages that have juveniles on them. So you could find out about something specific. So that was Crow Smarts. Now you may have noticed that I didn't read every single page on the book, and that is because I wanted to leave some for all of you out there who are hoping to learn a little bit more about crows to be able to check these books out or do some research on your own. There are a lot of great resources out there, and you can't learn about nonfiction subjects from just one place. So go ahead and get your research on, and I hope that you enjoyed learning about crows with this book, Crow Smarts by Pamela Turner, photographs by Andy Cummins, with art by Guido De Filippo. This book, again, published by Hofflin. Pages are sticking together. By Houghton Mifflin Harcourt. Once again, my name is Sarah Murray. I'm one of the librarians at Portland Public Library in Portland, Maine. This has been Learning with PPL, all about crows. I hope you enjoyed it, and I'll see you again soon. Bye!